I'm here. Hi, everyone. So I see 52 people. That's wonderful. My name is Francesco. I'm clearly Italian. And yeah, I will tell you a bit the story through the slides. Let me just scroll because I want to also see who is there. And by the way, let me remind you, everyone, that now we are using the chat of the session, because in Hopin there is the chat of the event and the chat of the session. That's where I will be. And also I will be asking a lot of questions. So if you guys want to answer, please use the chat of the session in the top right, not event, but session. All right, so let's kick it off. So what I will do now, I will share my screen and I will start presenting. So I share the screen and I see that you see my screen. That's perfect. So yeah, this is data preparation workshop. Let's kick it off. About myself, I am a consultant in business intelligence since 2001. So it means that I'm here at an event of data science, but I'm actually a person who has done always the traditional business intelligence. And somehow this is the reason why I'm very humbled to be here, to share my experience with people who actually know much more than me about data science, but I think I have some nice things to share with you guys, and I will really need your feedback. So I've always worked with the business objects, which is a software that now is owned by SAP, and with SQL language. And then I started to work with the databases and the data warehouses, because I wanted to understand what's happening with the data source. And I didn't have a very good understanding of why data looks a bit weird. So I went to work for Teradata, which is a major data warehouse producer. And then I started working in business intelligence with Qlik and with Tableau. And then now I'm moving to Python and R. So that's where I'm migrating towards data science. And it's being a nice journey. And the question is, how did I get in contact with the super data science community? Okay, so this is the picture of the person who got me in. So basically, I started to do, I attended a course of Tableau on Udemy, like probably many of you. And that's how I got involved into all the marketing emails of super data science. And then at some point, there was an invitation to an event, Data Science Go 2017. So this one was the very first event that Kirill organized together with all his team, and it was a blast. I loved it, and we were younger. Let me put it this way: we were younger, and in Data Science Go 2017, they were dancing. So you see Kirill on the stage dancing, and I think that there's some guys of the team, and you may recognize this one. I actually zoomed it. That's Paolo. And when I joined this event and I saw the dances, and especially Paolo dancing with so much style, I said, these guys, really, these are my guys. And after that, I joined the event of 2018, and I met friends that are very much my friends now, and I loved it. And I'm sharing also this. I know it's an event about data science, but I cannot not share this. So these are the shrimps that you can eat at the Pacific Beach fish shop. And these are actually one of the reasons why I was so excited to go to the event every year. And that's why I went also in 2019. And I loved it more and more. And also in the evenings, we were going out, we were having beers, and we were speaking about data science like horrible. We were never having a break, 24/7 data science. And this is the version of Data Science Go 2061. Okay, yeah, that's a joke. So basically, this is just to say that I love the event so much that I will continue going there in the coming years. And I really hope that the event will be live again. So it will be in person, because in person it is much better. Okay, so let's kick it off about business intelligence. I do business intelligence. So you may wonder, what is business intelligence? Most of you probably know it. Some people are doing data science, and actually they are doing it the way I do, like doing business intelligence, which is a descriptive way of interpreting data. And many people think that business intelligence is this, like doing these dashboards, which ultimately may also be true, but there are many steps before that. And sometimes, a bit ironically, I'm showing this slide saying what the BI developers think that the users do. So they think that they deliver a dashboard, and this guy and girl, these people at the cinema are like the end users saying, oh, wow, there's a dashboard, a bar chart. And they think that the users are eating popcorn and doing this, watching these charts. But it's not like that. So what users really do, they take all the beautiful charts and they turn them into Excel tables, and then they do pivot tables and VLOOKUPs, because data is never stopping. Data is a continuous flow. There's never like the final point. Wherever you will deliver data to someone, they will want to get your result and feed it in back to mix with other data. That's a never-ending cycle, which is good because it's also giving us our salary, and it's very reassuring to know that the flow continues. People do this. People need numbers. People need to see tables at the end of the day. Unless, okay, if they are top managers, they are happy to see charts and to put them on a PowerPoint deck. But otherwise, if there are people like you guys who are hands-on, you don't watch charts, you need data. All right, so a few words about data warehouse, and please be ready on your chat because I have some questions for you. Why do I mention the data warehouse? Because for people like me doing business intelligence, data warehouse is the golden source, is the place where you find all the data that you need. But question for you, and I'm actually reading your answers here in the other monitor. Do you use a data warehouse, and especially, do you like it? Do you trust it? Do you think that it could be improved? Do you think that it's a thing of the past century and everything should be a data lake? So I'm reading your answers here. I would really like to hear on the chat from you guys what you think about the data warehouse, because to me it's a key point, because I also believe that there is not much of dialogue between the world of business intelligence data warehouse on one side and data science on the other side. And this is hurting me because I belong to both communities, and I want to see a dialogue between these two communities. And I'm seeing this not only socially but also at work. I'm seeing that people don't trust data warehouses sometimes, and I want to understand why it is like that. So let's see if someone is writing. I see you guys are very shy. I need more interactivity from you. No one is writing anything unless I'm missing something. Chat, let me write something. No, actually I should write it here. Okay, 100% agree with all statements. Maxime. Okay, that's a nice beginning. Something more. It is easy to access, but it is vulnerable. I like, well, what is not vulnerable in any case? Everything, unfortunately, is vulnerable. But yeah, I appreciate the positive part that it's easy to access. And probably, Ahmad, you say that because you are saying that it's organized in star schemas. So in a structure that is very easy to access because you just connect a few things and it's ready to use. Tell me, Ahmad, if I'm correct. Svetlana says, it depends on business needs. Well, in theory, the data warehouse should accommodate all the business needs, and it should be the golden source for all information. Serge says, yes, I agree too. Data warehouses have a data quality problem. This rings the bell. I was speaking with Serge a couple of days ago, and we were having this conversation. So yeah, data quality problem. Of course, there is a big effort in trying to improve the data quality of data warehouses, but you always need to fix something. That's I totally agree with Serge. Type of data, is it more secure? Okay. We use data warehouses that is star schema. A lot of time is spent by our analysts to transform into data marts for different end users. That's very interesting. And Eogan says, just starting to implement DBT to try and help this process. And again, you will find me in the DBT Slack. I'm very active there. There's actually a channel called Modeling Pupini, because the thing that I'm presenting today is called the Pupini Bridge. And I have a channel with 150 people on Slack, on the Slack of DBT. Okay, so let's move forward. Thank you for the contributions. I will join. Okay, it will be good to see you. Wonderful. So my opinion about data warehouse is that this is how they tell you it is. So they tell you there's a staging area, and they tell you that there's a core layer, and there are data marts, and everything is ready to use. So user access, very easy. Except it's not like that. So sometimes at the conferences of data warehouse, where I was speaking 2 or 3 times of the Data Vault conference, I am a bit teasing, and I'm saying, guys, it's not true. The data warehouse that you prepare is good, but it's not final. There is still some work to do. So there is a layer. So there are the famous 3 layers: staging, core, and data mart. But then there is a layer that I have called the phantom layer. You don't see it. You don't know that it's there. But everyone is doing more transformations after the data marts are prepared. So there's a continuous work that needs to be done. And that's what I'm trying to address with my work. I'm trying to make this additional work a bit more smooth. Okay. So data sources have many tables. And potentially, these are in many systems. Imagine this is a screenshot from a test database called AdventureWorks. Many of you know it is from Microsoft. It looks complicated, yeah, but it's just one source. Imagine that typically, if you do data science and you need to train a model and you need data that comes from many systems, you have many systems that look like this. And you need to make sense out of all these things and put them all in one place and generate a model. So there's a lot of work to do. So how can we simplify all this? Imagine also for data preparation for machine learning, it's time consuming and it is risky. So yeah, it's about cleaning data and it's about a lot of issues that you can have. So I need to remove this. We need to simplify the data prep for both business intelligence and machine learning. So we need to find a solution that reduces the time that we all spend on data to fix data, because data is always full of problems. Right, so what can I do about that? I will show you today. So today is mainly interactive, and I will make, if we manage it, 4 demos. So we will go through join versus association. It's a thing that I will tell you in a minute. And then I will show you that you can do aggregation and then join. And this is something that works, and that's probably what most of you guys do. But that's ad hoc, meaning that depending on requirements, you need to rework again. And that's the thing that I'm trying to eliminate. I wrote a book that is trying to eliminate this ad hoc effort. Ad hoc means on purpose. It's Latin. It means on purpose. So we need something that we build and it's reusable. We cannot spend our life doing all the time the same joins for a slightly different requirement. We have better things to do. So my demo 3 is union and aggregation. So instead of aggregation and join, I propose union and aggregation. I'll show you why that is more flexible. And then I will show you the Unified Star Schema. So there's a lot of things to go through. It's 7:18. I am in Central Europe. I'm in Poland. So there's something like 20 minutes to show all these things. So it's impossible. 20, 25. But let's try. And by the way, this is my book. It's called the Unified Star Schema. So we all know what is a star schema, a data mart with a fact table and the dimensions all around. The Unified Star Schema is an idea that I have invented that takes all these star schemas and puts all of them in one star schema. So basically, all the information that you need, you find it in one place, because otherwise the problem is that you find a piece of information here, a piece there, and then you still need to do a work, the famous coding, the famous additional phantom layer transformations, because you need to sew together pieces which are in different places. So I said, let's make a unified star schema where you put at the center, not one fact table, but you put a table called a bridge. And someone told me, call it the Pupini Bridge. And I said, it's a bit of a funny name. but they said, okay, but it will work. So now most people are calling it the Pupini bridge, which I really find funny. So it's the new thing that you put at the center of a star schema, and you will see it during this demo. And if we don't have enough time, we will try to organize another workshop because there's a lot of things to share. All right, and that will be the last slide. So meaning that now we focus on the demos. Because this is going to be very interactive, I would like to ask you if you have things to share. So I'm checking the session chat. People have a different opinion about data market definition. Yeah. Okay, so I'm starting with the first presentation. So let's say there are 4 demos, join versus association. There's a thing that most people don't know. When you have 2 tables, normally you say you need to put them together, so you make a join. But that's one of the things that you can do with 2 tables. You can do other things. And I'm talking, when I say join, I'm talking about SQL language, the SQL command join. Of course, if you're using R or Python or other languages, you may have a different command, but basically SQL is quite useful because you have just one command, while in Python, especially in R, you have so many different ways to do the same thing. So the SQL join and the association. The association is actually short for in-memory association. And it's a thing that I'm doing presentations about this thing since, I don't know, 5 years ago or 10 years ago, because it's a thing that not many people know, and you will see it with your eyes in less than 3 minutes. So let's kick it off, and I'll take a data set that I've prepared for this event. It's called data source, very original name. And one recommendation I have for everyone: before you start, watch your data. Just open your data and watch it. See what is there, see if the tables make sense to you, if the names of the tables make sense to you, if the names of the columns make sense to you, because then when you will write code, you will make assumptions on data. No assumption. You watch it and you know what you're joining, right? So the first table we watch is called products. So I've made an imaginary company that has 4 products, product 1, 2, 3, and 4. They all cost 60 euros. And they are sold at 100 euros. So imagine a company that is buying something and reselling, not manufacturing, they are just buying and reselling. All right, so here are the 4 tables: products, purchases, sales, and shipments. Self-explanatory. So imagine a story that I have on the 1st of January, I buy the 4 products. I buy 4 units for each of them, by 60, 240. And then later I will buy some more products. And then I start to sell them, and I begin to receive the orders. So on the 1st of January, I receive an order from Mr. Bill, who wants product number 1 and wants 1 unit. So I'll sell it for 100 euros. And then I'm European, so I call it euros. On the 2nd of January, Bill says, okay, I buy also product number 2. And again, I sell it for 100 euros. And then on the same day, Francesco buys product number 2, but he buys 2 units. So it will be 200 euros. And then Francesco buys product number 3 for 100 euros. And then on the 4th of January, Francesco wants product number 1, but he wants 4 units. But because I only bought 4 of them, only 3 are available now. So there are not enough units in stock. And this is one of the problems that you have normally in business. And final table, shipments. So the table of shipments, tells us basically what is happening with the shipments, and all the others are shipped correctly. But this order that Francesco made on the 4th of January that wanted 4 products, 4 units of product number 1. So what happened is that it's broken into 2 shipments. So first we will ship 3 units, and then we will ship 1 unit. This is our data set. As you can imagine, now the challenge will be how to put together these 2 tables, because they have a different granularity. They have a different number of rows. So a different number of rows. I open Tableau and we load these tables and we see what is happening. So I open my data source and I start by shipments, and then I drag sales. And Tableau is asking me how to join these tables, and it says shipment sales ID and sales ID. This is the way to connect the 2 tables. So basically, if you look at the tables, it's like that. There is a shipment ID and a sales ID. And for each shipment, it says this is based on the row number 5 of the sales. So this is the row number 5 of the sales. So we need to join by the sales ID and the sales ID that is in the shipments table. So now that we are here, we join shipment sales ID with sales ID. Okay. Now that is done, I can prepare a report. And we will have very soon a poll because I need to ask your opinion about something. So let's say that I want to see how the fulfillment was if I've been able to ship to my clients all the things that they were buying. So I can put the shipment ID, the sales ID, and then I can put the shipment amount. And in Tableau, you can do the total to see what is the amount of money that the value of what I've shipped. So it's 900. If you look at your data source, it's 900. So that's the correct number. So that's the value that my clients want to be shipped. And by the way, 900 is also here. So now I remove for a moment the totals, and I will put the sales amount. And this is now becoming interesting. And I really need your attention on this, because I will show you the difference between a join and an association. When you have this data, you see that the shipment amount and the sales amount, they are, let me sort it, just a moment. Okay. So, sorry, I wanted to, yeah, there's one thing that I wanted to add, shipment ID, I wanted to put. Okay, that's what I wanted to obtain. So as you see, the number 400 is now repeated. So if you do the sum of these numbers, you will have 900. But if you do the sum of these numbers, you will have clearly a number that is bigger than 900. So I would ask our moderator to launch the first poll, because I would like to hear from you what you think that Tableau will show when I go to show the totals. So for the shipment amount, I will clearly have 900 because that's the sum of these numbers. But for the sales amount, what is the value that I will have in your opinion? So let's see, soon you should see a poll appearing. And please, I don't know if you see my screen enough big. So I would like everyone to vote and to tell me if you guys think that the final number, the total of sales amount will be 900 or 1300, or if it doesn't make any sense at all to you. Okay, so I'm seeing the progress of the votes. Until now, only 9 people have voted. So I repeat the question because it's very important. I hope you see the screen big enough. So yeah, the total of this column, sales amount. So let's do it. 4 plus 4, 900, 1,000, 1,100. So if you do the sum of these numbers, it's clearly 1,300. Okay, I see that the votes now, 14 people have voted. So when I will put the totals, you will see the result. Guys, don't be shy. There are 62 people. Only 18 have voted. What will be, in any case, it's anonymous. So I will not know who has voted, who has voted what. So I'm checking. Okay, you're being shy today. So apparently not many people are voting, so we can display the result of the poll to everyone. So we can see how the votes went. Okay, I'm seeing that people are beginning to vote now. So let's probably give them another few seconds. This question is very important because it is one of the central differences between data science and traditional business intelligence. Traditional business intelligence is done on business intelligence tools, and they these tools are very smart because they are done for the end users. But the problem is that when you do data science, you're putting your data in a data frame and you're putting everything in a table. And trust me, the numbers that you obtain in data science are different from the ones that you obtain in a tool of business intelligence. So it's being interesting. No one has voted error message, I'm seeing already, because with my second computer I have voted, so I'm seeing the partial results. Okay, I guess we can show the results. We have 30 people who have voted. I don't know if they have been already shown. Now I'm confused because I'm seeing them because I have voted. But anyway, the result here is that 10 people have voted 900 and 20 people have voted 1300. Okay, so now please go back to my screen and let's focus on that. So if I now put the totals, it will show 900. So 10 people were right and 20 people were actually not predicting what the tool will show. So you may wonder, how is it possible that Tableau is showing these numbers and it's saying 900, although clearly the sum of the numbers above is not 900? Well, it is possible because Tableau is aware that the tables have a different granularity and it's treating them in a different way. So let's go to the data source. When you go here in the data source of Tableau, many people were answering in the chat, I see. Okay, that was a poll. So next time, probably you can vote in the poll. So we have better statistics. But okay, so we have the shipments. And as you can see here, these are 6 rows. And you have the sales. And these are 5 rows. So Tableau is not merging these two tables into one table. It's leaving them as separate things. And in the moment when you merge them, they become only one thing. But because they are two different things, then Tableau is saying, I know that the total of sales, regardless of repetition, is the sum of these numbers. And 4 plus 5, 7, 8, 9, the sum of these numbers is 900. So when I will display the sales amount, regardless if that number 400 has been repeated, so it's been copied twice, I don't care. Tableau will say, I don't care, I will put 900, so I will put the correct number. So this is a thing that I suspect that not many people know, and I think I was sort of right. But now I will show you another thing. The one that you have seen now is not a join. It's called in-memory association, or in Tableau, it is actually called relationship, although relationship is a kind of a funny name because it has multiple meanings. Now I will show you that Tableau can also do the join. So I will take now again the shipments. And then instead of dragging the sales as I did before here, you see I was putting it here, I put it inside. So I double click and I put the sales here. So this is doing something completely different because now I say again that I joined by sales ID and sales ID. But this time, Tableau is denormalizing. What does it mean? It means that it's taking the two tables and like the second table is absorbed into the first table. So it's a logical table, shipments, but physically it has shipments and sales. So the result is a table of 6 rows. So be prepared, watch carefully, because now there will be the second and last poll of today. So you will have to answer again. So in the first example, we have done an in-memory association, and the result was 900. Now we go here to the sheet, and we do the same thing as we did before. We do the shipment ID and shipment sales ID, and we do the sales amount, and we don't put the total, and we put the shipment amount. Okay. So now that I have these numbers, I have a question for you guys, and please, I ask my moderators to run the second poll. Now that you are seeing a thing that is identical to the one of before, but this time there is a join. So in my data source, the two tables have been merged into one table. While in the previous example, I'll show it to you again, in the previous example, the two tables were separated. You see 6 rows and 5 rows. So now, in the example that we are doing now, they are merged, and it's 6 rows with all the columns in a table of 6 rows. So there are the columns of sales and the columns of shipments. So now I go to the same sheet, a sheet that has the same layout as the previous time, and I'm asking you, so what will be the result now when I go to put the totals? The total of sales amount now, is it going to be 900 or 1300? So the possible answers are 900 because that is the correct number, or 1300 because everything is one table, is in one table. I see you guys are going very well. I'm seeing already 20 votes. And I ask you to continue voting. And I'm telling you why this is so important. Because when you do data science and you're working with R and with Python, you do not have the in-memory association, at least not to my knowledge. And if you know that some solution allows creating something that is similar to the in-memory association, please let me know. So to my knowledge, it's impossible with R and with Python. It's impossible to emulate this behavior that you have seen in the first example. It's impossible to produce a table that behaves like that, especially because in these programs, you don't do the total. So you simply produce a table, but if at some point you produce the total will be not 900. It's impossible, to my knowledge. So I think we can close the poll, and we can display it to everyone. And the result is that 25 people have voted 1300 and 4 people have voted 900. So let's go to see in Tableau what is happening. We go to see, we do analysis, totals. No, sorry, I'm in the wrong sheet. We go analysis, totals, show column grand totals. And this time, for sales amount, the total is 1300. So what has happened now? We have done a denormalization. When you take two tables that have different number of rows, they have a so-called grain shift, and we have put them together in one table. In that case, you can't do anything. You have a repetition of a number, and that is a problem. It's a problem that today does not have a name. So again, I have a question. If you guys, so I'm asking here in the chat, if someone thinks that is written somewhere in literature or in the documentation of your software, please tell me, because I have never found a book that explains the difference between a join and an in-memory association. That's why I wrote a book where I explain that. So I can show you what I did. This is the PDF of my book. I can show it to you. And I've given a name to this thing, and I've called it Fun Trap. Actually, Fun Trap is a name that already existed, but it's not described the same way. So I want to show you very quickly not so quickly, the Fun Trap. So I have given a definition to a structure that has two tables. One points to the other, like shipment points to sales, or sales to products. And I have made the case when the table that is pointed contains a number. Well, it's inevitable, mathematically inevitable, that in the moment when you merge these two tables together, all the numbers that come from the table that has been pointed, so the one, because you have a foreign key pointing to a primary key. So it's mathematically sure that you will produce numbers that are wrong. It's sure, unless you have a business scenario where every order that has been done by every client was always shipped in full. In the moment when just one person is ordering something and is shipped in two shipments, well, in that case, you will have a grain shift, and the two tables will not be allowed anymore to be together. This Fun Trap is the source of all problems in data. When you're working in a company and you have a problem, probably it's a Fun Trap. I think that the name of Fun Trap comes from the fact I've put in the book a photo of a flamenco dancer. that you basically create a number and then you spread it like a fan. That same number, like you saw the 400 is repeated, it's spread like a fan and the number is repeated. So when you are training your machine learning data model and you have taken numbers from a table that had a lower granularity, well, you have brought into your model copies of a number. So the only thing that you can do is to aggregate, so to bring the two tables at the same level of granularity. But in that case, you are losing detail. So I am clearly not managing to show all the 4 presentations because we are already at 7:40. But I want to tell you very briefly what is happening. So what I guess you guys are normally doing, in the meantime, I'm checking the chat. Not written anywhere, but we call this a fan out at our work. Okay, Eogan calls it fan out. Fan out is a name that comes from a Looker. So in Looker, they call it fan out. And if you look at the Looker documentation, look at the Looker, you will notice that the fan out is described in different documents in a slightly different way. And I could speak 2 hours about the fan out of Looker and explain you why it is a big problem in Looker, because Looker is producing a formula of 25 rows to solve the problem of the fan out. And it's something that I have eliminated. The book on Amazon, okay. Spurious tuples, that's interesting. Okay, I will go through this. Okay, of course, as usual, I'm not able to go through all the answers. But I want to tell you what are the steps. So what I think that you guys normally do at your work, I suppose that you realize that there is a risk of creating duplications. And for this reason, you are aggregating before joining. So what you would typically do, you would, before this call, I prepared all the examples because I knew that I would never be able to do them together with you. And so what you would do, sales aggregated somewhere. I created an example where I was merging them. I will not find it now, sorry. But what you do, basically, you take your shipments and you aggregate these 2 rows into 1 row. So this way you bring the grain shift to 0. So everything will be lining up perfectly. But then you're losing an information. You're losing the information that the second shipment was done on the 10th of January. Or you're losing the information that it was 300 and 100, could be 200 and 200. So the thing that I want to avoid is to lose information. So for this reason, I have proposed something different. Instead of aggregating and then joining, there is another option, that is to make the union and then the aggregation. So this union and then aggregation is more flexible, because when you do the union, like the SQL command union all, you basically put the rows underneath each other and you pile up in the same column the things that have the same meaning. So you pile up the dates together and the product ID together. When you do these things, what is happening is that all the details are there. So you have the 5 rows of sales and the 6 rows of shipment. So you have 11 rows. You have not lost any detail. And in the moment when you want to do a particular visualization, you are able to line up the things, but inside your, as a post-production. Imagine you create a data frame in Python, which has 11 rows, and then you want to compare the sales with actual shipments, then you do temporary an aggregation, but you still have the original rows. You don't want to lose data. And then finally, I want to show you that the Unified Star Schema is based on the concept of union and then aggregation. I know we have just 1 minute, but I think it is worth giving you a quick demo of how the Unified Star Schema works. So I will open now Tableau, and I will show you how we can work with the Unified Star Schema, how it looks like. I know we should start the Q&A section in 1 minute, but bear with me 3 more minutes, and you will see the Unified Star Schema. So I've prepared the same data source, but this time I have organized it my way, the way as I described in the book. So this time you enter this data source, and you will see not only the 4 tables that we originally had. So the purchases, the products, the sales, and the shipments. And by the way, I've added a calendar. But you will also have these 4 tables called PBS. So you have products and products PBS. PBS means Pupini Bridge Stage. So imagine that there are stages that need to be unioned together, and they together create this big table called the Pupini Bridge. Of course, if you don't need the purchases, you don't pick them. So basically, you start your query by a generic dummy table that is empty. So this table, all data, I can show it to you, is a table that is empty. And then we union underneath that table. You see, this is all data. It's a table that a column called stage and 0 rows. And then you union underneath that table the other pieces of Pupini Bridge. So this and this. So these are only keys. So PBK stands for Pupini Bridge Key. So basically, you are playing as with Lego. You pile up things, and the columns will pile up automatically. So purchases will pile up with purchases, also if they are in different positions. That's how languages work. That's how Tableau works. So I start by piling up products. So I put not like that, but I put it like that. It's a union, you see? And then I do the purchases, union. And then I do the sales, union. And then I do the shipments, union. So now I've created a Pupini bridge that has everything. But of course, when you deal with with a lot of rows, you just pick those 2 or 3 things that you need for a particular analysis. And then what I do, I join all the other things. Well, I in-memory associate, in this case, all the other things. So I want to put the purchases, for example. So I double click, and I'm not touching the keyboard. You see, it has already joined correctly. PBK purchases, PBK purchases. And then I double click on sales, double click. I don't touch the keyboard. Oh, sorry. This time I put the wrong table. I tend to do that. It's not sales PBS, but sales. So I double click on sales, and it's automatically joined. So you don't need to care about joins anymore, because the engineer who has designed the Pupini bridge, so if you have a company, you have 100 tables, you call a person like me, and we do the job of creating the Pupini bridge stages, and then no one needs to do joins anymore. You can play with data happy ever after. So, oh, and someone tells you, but we need to know information also about the shipments. No problem. Double click on shipments. Double click. I don't touch it. It's automatically joined. Everything is automatically joined, not only by the keys, but also by the aggregators. So in the moment when you want to do an analysis by a detail, for example, let's put also the calendar. Okay, I want to watch the calendar, and it's joined automatically like everything. So not only you've joined by the key, but you can say that you want now to make an analysis by some column of the calendar which is aggregated. For example, the weekday, and you want to compare the sales and the purchases by weekday. So you put the purchase amount, the sales amount, and the purchase amount. And you can also put the shipment amount. So every time that numbers have a reason to line up this correct row, like Sunday, Wednesday, they do it. Basically, you have all the tables already automatically pre-connected with all the possible combinations of aggregation. And then you have all your free time to play with your data. I think this was a bit quick. Of course, I could speak about this topic for hours and hours and hours and hours. But yeah, I would like to have a feedback from you. So I believe that we can start a Q&A session. Don't we have another hour? That's sweet. we can see. Now, yeah, we do have another hour. The way how this event is organized is that it's 2 hours, but the second hour is one-to-one sessions. So when we will finish, then the second hour, I will be still here, and I will be speaking with some of you randomly, and you guys will be speaking to each other randomly. So the time allocated for the event is 1 hour, but I agreed with Diane that we can do the Q&A a bit beyond the hour, hoping that it will not cause any trouble. Thanks, Francesco. This is good stuff. Thank you, Robert. Okay, did I start from the beginning? Okay, that's a long one. Yeah. And then the last hour might be networking. Yes. Q&A tab. So I don't know if there are already questions in the Q&A. Yeah, there's one. And I'm going through the chat still. Grazie mille, Elissa. Okay. Okay, so Alexander is asking. So take Salesforce as an example. I stack all of these tables I'm interested in my data warehouse. Then from the table, I can extract all metrics, not tableau focused. No, don't worry, it's not tableau focused. This that I'm showing is generic. It's valid for everything. So let me unshare my screen so you can see me face to face. So the answer is yes. And if you ask, have you tried it with Salesforce? No. I have done this project 6 or 7 times, Unified Star Schema based on the Pupini Bridge. But every time I had up to 50, 60, or 70 tables. And yes, they were fitting all together. Actually, I can reshare the screen for a moment because there is a thing that comes to my mind. I wanted to show you a project that I've done for a bank. And I think I have a slide, or actually I can show you more interesting. I can show you AdventureWorks, that big database that I've shown you earlier, how it is with the Pupini Bridge. So this is loaded in ClickView, not in Tableau. And if you look at the data model, that's how it is. It's a bridge in the middle. I called it bridge because I didn't want to call it Pupini Bridge. And these are something like 70 tables, and they are all related together. So imagine that this is your Salesforce. It is not, but imagine. So if I click, for example, on a calendar, like on a few years, let's say I want to select a few years, then automatically in blue, I have all the tables that have some data that happened during those years. So this is multi-fact. You have the purchases, you have the sales, you have actually the manufacturing. Everything is connected together. So I have made this giant Pupini bridge that somehow glues together things on demand. So whenever someone makes a filter, that cascades everywhere. So yeah, to finish the answer to your question, yeah, basically the answer is yes. Of course, you have to define a thing called the BI domain. So Salesforce will have probably 500 tables, okay? But you have to focus on what you think are the tables that are relevant for your business intelligence. So there will be probably only 200, okay? 200. And if you have giant data volumes, then in any case, in business intelligence, you need to build aggregates. But these are the aggregates that you need to do because you have no alternative, because too much detail, 10 billion rows don't fit into a BI tool. So in the moment when you have defined the tables that you want and the level of aggregation which is compatible with your systems, then this is your BI domain. And starting from that, yes, you call me, I pile them up, all 200 tables. Okay, I don't understand what the bridge is. Can you show us a table what it looks like in the bridge? Yes, this is a question that I'm receiving a lot. So it's from Ariel Tal. So I will show you the bridge. Okay, so I have it here. So this is my data. Oh, am I showing? Yeah, I'm sharing. Good. So this is my data. These are the tables that you saw before, but to each table, I have added one more column, which is the PBK column, Pupini Bridge Key. So if you are in products, you have one first column, which is called PBK products. If you have a table called XYZ, your first column will be PBK XYZ. So it means the unique identifier for that table. If you have a sales table which has no identifier, you need to build one. One thing that is imperative is that every table must have a key. Does not need to be a business key, can be a surrogate key. So, for example, here I have purchases, PBK purchases. So it's a copy basically, because here I have a key. So shipments, you have shipment ID and the shipment ID also here called PBK shipments. Why do I duplicate that column? Because this column is a system column, and that's what you will find in the bridge. the Pupini bridge key. So all the other columns are considered business columns. So you can decide that you want to watch the shipment ID. It could be an information that is relevant for reports. But these technical columns, you will never put in reports. You just use them for creating the joins. Now, back to your question, you wanted to see how the bridge is built. So let's start by this. The most important table of the bridge is this one, the empty table. So it's your starting point. It's a table with one column and 0 rows, and it's called stage. The table, you can call it all data or whatever. So this table has no data, but it's your starting point. Then you start to append the other table. Imagine, let's make an example, that we want sales and shipments. So we take sales, I copy it, and I put it here. Okay. And then we take shipments. So I go to shipments, I copy it, and I put it here. So now what is interesting is that all the BI tools and all the languages automatically do that exercise of piling up correctly. So now things are not piled up correctly, right? So as you can see, they are not. So what the tools do, they say, okay, the first key is PB sales. I have it, yes. So I put it here. And that's what the tools do automatically. You saw it earlier today. Then PBK products, I have it, okay. So it piles up correctly. It goes here. Then PBK shipments, it was not there yet, so it stays here. And the calendar is there, so I put it there. All this work I'm doing now to show it to you, but it was done automatically 10 minutes ago in front of your eyes. And then these are numbers. There's a reason I cannot explain it in this meeting, why also the numbers, a copy of the numbers is going to the Pupini bridge. So this is the Pupini bridge now. It's basically, now I don't need these headers anymore. Okay. So probably if I want to do a nicer job, I probably move everything. I like it more when you have all the keys first and then all the numbers. So I would put here this of the shipments. Okay. And then this, we remove it. So what is happening now? I have built a table where this line of headers is not needed anymore because everything is piled up when available. So this is a sparse table. It has holes, okay? And that's the beauty of it, because it connects whenever it's possible to connect. Otherwise, it doesn't connect. Like apples and pears, they are not connected, so it will not create, it will not populate the block. So these are all blocks, and they are telling us that shipments is able to point to products. Sales is able to point to sales, to products. So it tells us what points to what. And thanks to this, we are able to build a sort of a big telephone switchboard where all the phone calls are enabled. Anyone can call anyone unless the block is empty. Okay, so the bridge table will have a lot of rows and columns depending. Okay, that's moving. Depending on the amount of tables and their key columns. Have you run into any issues where you have exceeded the limits of rows, columns in a table? It's a good question. I haven't, but it's also true that I was working in projects that were for big organizations, but with not too much. When you have 70 tables, even if it was Deutsche Bank, it was not too difficult. But it is possible in general. That's why I have built it as it's modular. So you are the one who is deciding. You remember when I was here in Tableau and I went to the data source and I went to this all data thing. I have put everything and I said, I can put everything because I know that everything fits. But I can always say, okay, this is too big, I don't need it. This is too big, I don't need it. So you just put whatever you would have put in a normal report that you would do with the Kimball approach. So if you want to put too many things today in a Kimball report, and they don't fit, well, they don't fit. It's a system problem. So you need to make aggregations. But whatever you can do with Kimball today, you can do it with the Unified Star Schema, because Kimball is totally inside the Unified Star Schema. Unified Star Schema is a generalization of Kimball, and whatever report of Kimball you have, you can do the same identical report with the Unified Star Schema. Okay. So if I understand correctly, they are sorted by rating. So, okay, that I've answered. Now, Israel. Hello, Israel. Nice to see you. I've seen vendors talking about using a knowledge graph to solve for those same issues, exploding metrics and not knowing how to join tables together. Have you tested these types of products out? I haven't. Thank you. Let's take it offline. In any case, we have already had phone calls, so we can speak about that. That's super interesting. I would like to see that. Question. Okay, that's. So Maxim is asking, if I have millions of rows for fact tables, will bridge table have these millions rows, or it should be reduced? Tableau was not able to handle 1 year of data for me. Okay, Maxim, thank you for this question. It's so important. This is a key point, and I need to explain you why the Pupini bridge is magic on this. So you're speaking about 65 million rows. I've tested with billions of rows, because if you take Snowflake, I've done a test with my friend Roberto, and we were testing in Snowflake. There is a test database. Let me stop sharing so you can see me. There is a test database which is replicated in small, medium, and large size. So what I've done, I've built, actually my friend Roberto has built for me the code in dbt to build a Pupini bridge, where all the stages are physically stored, and then a view is merging them together. And then imagine that you take that and you pull it inside your Tableau. So Tableau, you need to have, of course, a live connection. You cannot have an extract connection, because if you put Tableau extract, that will pull 65 million rows. So you cannot do it, neither with Kimball, not with Pupini Bridge. Simply, you don't want 65 million rows to travel through the cables of internet, knowing that at the end you will want to see the aggregate by year, or by, actually that's 1 year, so you will want to see the aggregate by country of client or whatever. So of course there is a concept called push down technology. So you tell Snowflake what you want, and Snowflake says, wait a minute, I am Snowflake, data is here, I don't make all these 65 million rows travel. I do the calculation and I send you the result. That's the push down optimization. So the Tableau live connection is doing exactly this. In the moment when you in Tableau drag country and sales amount, well, if you have 20 countries in your sales, you will see 20 rows. And in that moment, you're generating a query to Snowflake that takes your 65 million rows, does the group by country, and on the cable of internet, you will have 20 rows traveling, not 65 million rows. So when you have big volumes of data, you need to use in Tableau the live connection, but that's true in general. And the live connection is the new thing that will be more and more important. That's why Qlik is now in trouble, because in Qlik, they don't have the live connection. In Qlik, they pull all the data. But talking about machine learning, well, you need to have, in any case, your system capability. That's something that I cannot change. So in the moment when you are generating a query in a BI tool, you have this capability to generate the live query to the Snowflake or your cloud database. We need to find, and that's why I call this a workshop, we need to find the equivalent in machine learning, because I don't know. I am a business intelligence person, and I would like to make an open call to everyone. Please help me to build the same test case. I will produce videos for Tableau showing how Tableau does the push down optimization with the Snowflake. And I will say the same way as Tableau does this, let's see how we can do it with the Python. And that's where I need your help, basically. All right, so the bridge table will have a lot of rows and columns depending on the amount of tables. Okay, that's I've answered. Exceeded the limitation, DBAs, performance has gotten affected greatly. Okay, that's now the order of the questions is sorted, so that's an extension of a question that is somewhere else. Is this approach expensive in relation to memory and processing? Well, I guess this question, Antonio, Luis Antonio, is answered by my previous answer, because that's actually the whole point. we need not only to save efforts to the humans, because we want humans to have more free time for their family or to be able to go to the beach. So we want to avoid that we spend too much time doing boring coding. But we also want to save time to the machine. So it's very good that you're asking if this approach is expensive. It is as expensive as it is with the technologies that we have. I've never been a fan of Tableau, but I have to admit that they have introduced this live query that is a new technology. I was working for 10 years with business objects, and business objects was producing live queries only when the user was launching them. It was a very mechanical thing, while Tableau has made this thing much more fluid, user-friendly. Every time that you drag and drop something, you are automatically generating a query. So, of course, if the end user is pulling the column called sales ID, like imagine it's Amazon, and every order in Amazon, when you receive the email, there is the Amazon order, and it has 24 digits, okay? So if you pull that column, that of course will generate a lot of traffic on the cables of internet, because let me tell you, it's an irresponsible query from the side of the end user. So our aim is also to educate the end users, or to make sure that they will not make irresponsible queries, for example, by using metadata. So with metadata, you know in advance how many rows the query will generate. And if the rows are 3 billion rows, you put a warning, say, hey, we don't want 3 billion rows traveling on internet, because if they travel on internet until your computer at home, then you read them one by one. Okay, so we don't believe you that you will want these 3 billion rows. So ask a smarter question with fewer rows, and then you will receive these rows in a very cheap way. So the answer to Luis is, using metadata, we can build security gates that are ensuring that the question is not irresponsible. Alexander Butler, in dbt, how would you materialize this model? View table incremental. There are a few things. Of course, whatever is incremental is a table, so it's physical. So the question is, whatever you do incremental today will be incremental also inside the Pupini bridge. So the question is, what is a view and what is a table? The strategy that we have put together with my friend Roberto is that the Pupini bridge stages, these PBS tables, they need to be physical tables. But the big Pupini, my friend is Italian, he calls it the Pupinone, so the big Pupini. So the Pupinone is a view. So you don't need to make a physical copy again of all these rows in your database. That's expensive. So the idea is that you basically have a bit more of expense, because for each table, you are additionally storing also the PBS tables, which are a lot of rows and not many columns, typically 4 or 5 columns. But yeah, that's an additional expense of storage, but that saves you all these thousands of data marts that organizations have that are storing data physically everywhere, and then they forget about them. So this way you have a clean environment where the tables are physically stored. I call them base tables. The PBS tables are physically stored, the Pupini bridge tables. The Pupinone is a view. And for those tables that are very big and you use incremental load today, you will also use incremental load tomorrow, because most of the things that you are doing today, if you apply the Pupini bridge and the Unified Star Schema, they are remaining like that. The only thing that I'm adding is these pieces of connector that make your life easier. Okay, I guess I'm answering still a couple of questions. I'm receiving a message. Feel free. Okay. So we still have time. Yeah. So thank you for all these questions. There are a lot. Again, because this is sorted by. No, it's sorted by time. So in the BT. Okay. So Sheikh is asking, what is your recommendation on tools like Click that like to cache everything? How can we implement this solution in Click with heavy data sets? Sheikh, I'm sorry to tell you, I've tried all possible ways. I've worked with a team in Kazakhstan who is They're really specialized in click, and they have explained me that today, even with this technology that is creating the application on demand, this on demand app generation, even in that case, that's not the answer, because click natively, it's not only about caching. Caching is somehow they try to help, but the ultimate goal is that inside the server or the farm of servers that is hosting ClickSense, well, they want to store all the detail. The initial concept of Click is a concept from the 90s. Today there is big data. So if Click does not come with a solution that copes with big data, they are out of the game. And there is no Pupini bridge that can help them. I'm sorry. Okay, so is this material written down anywhere so I can read it over and chew it? Colin. Well, it's written on my book. My book is on Amazon, and let me be honest with you, I'm probably earning $4 for each book that is being sold. So I'm not. I would give it for free, but I hope my publisher is not in this call. I'm not allowed to give it to anyone. Even my copy, as you have seen, there is. I show you how strict everything is. In every copy, am I sharing the screen? No, I'm not. So let me share for the screen for a moment. In every copy, there is in the footer of each page a text that says who has made the order. And when you're buying the PDF online, they ask you for your real name and surname. So basically, there's no way out. This PDF copy, if I send it to someone, I am liable. Like I really risk troubles with the publisher. So I cannot give the copy to anyone. The only thing to do is to buy it, and it's not even cheap. It's $50. In the future, I will publish some data on GitHub, some code, I mean, and I'm planning to make videos, but at the moment, not much material is available other than the book itself. Okay. Okay. Arialtal, I'm having trouble understanding what the bridge accomplishes. Okay. It's a very straight question. So let me give you a very straight answer. Today, and I've done 35 projects since 2001 in 35 different companies. Today, every company has a bunch of reports. I'm talking about business intelligence. Then I will talk about machine learning. When it comes to business intelligence, companies have a lot of reports because they make copies of data everywhere. So there is a mess. If you go to any company, they will have reports that they keep because they don't know if someone is using them. And there are copies and copies and copies. Why do you copy data? Bill Inman, my co-writer of the book, who is actually the father of data warehousing, he says, people copy data because data is easy to copy. Yeah, okay. But why do they need to copy it in the first place? They need to copy it because that's the natural thing. When you have a report request to see sales by customer, you store a copy of data with sales by customer. Then you have another request, shipments by shipper and date. Then you store another copy of data. So you are accumulating copies of data. While the concept here will be that data is each data atom, each data unit is stored on disk only once. And everything that you have is your visualization of the report that you are free to throw away. But the maintenance is super easy because you are maintaining just the original copy of the data. You don't need to maintain all the other derived copies that go out of sync. Basically, I'm tidying up the data of the organizations. That's the main thing. The other thing is that it's much easier. So you saw it when I created this Tableau report. I just drag and drop. Otherwise, you need to go to the documentation and see what is the foreign key that is pointing to the primary key. And that's time consuming. I want to save your time. And that's exactly what I can do for machine learning. You guys don't need to go anymore to the documentation to see how things are going, because you just take these pieces of Pupini Bridge stage and you put them together. If they don't work, someone else has already shouted at me because they are just one copy. So if it doesn't work, I'll fix it. But in the moment when I fix it for one, I fix it for everyone else in the business intelligence department and in the machine learning department, in the data science department. So the advantage is that I reduce the copies of data and I make life easier for everyone because everything is pre-connected and you don't need to care about creating connections. Okay. Luis, can you comment about the fun trap? Could you please comment the chasm trap? Okay, so it's too long for this call, but basically these two names, they already existed. But if you go to Google fun trap and chasm trap, you will find definitions that are very confusing. So the one that is called fun trap in Looker is called fun out, but they define it differently. And the definition of fun trap is based on 3 tables. But the problem that they point out exists also when you have 2 tables. That's why I've given a definition which has 2 tables. One has numbers and the other explode the table that has numbers. So simple. I don't know why for 25 years, the definition of fun trap included an additional table that does not have any impact in the creation of the problem. Even if you remove that table, you still have the problem with the 2 tables. Chasm trap is actually a system of 3 tables that somehow are incompatible. They created a chasm between the 2 tables. So that takes too long to explain. My chapter of the chasm trap in the book is the longest. I can share it for a minute. It's the longest chapter because it goes through a lot of concepts before arriving to define the chasm trap. First of all, you need to understand a Cartesian product that almost everyone knows what it is. By defining the Cartesian product, I make a differentiation if a Cartesian product is useful or not, because you can do it on purpose, like weeks and weekdays, I make an example, but in most cases, data is like apples and pears. So you create a Cartesian product that says, okay, this is a pair, Cortland, Anjou, Fuji, Anjou. You create all the crosses of all the combinations of things that have nothing to do with each other, like apples and pears. So most of the times, a Cartesian product is wrong, 90% of the times. And a chasm trap is creating, for each common element, a Cartesian product. So I'm going through an example of LinkedIn, and I'm explaining that in LinkedIn, if you have your skills and your languages, these are 2 things that are very nice. The common thing is you, but if you know SQL, JavaScript, and Python, and English, or even better, user 3 knows SQL, Python, and PHP, and speaks English and German, how can you put these things together in a table? You're clearly creating six combinations, and that's not adding any value. So this is a Cartesian product. So the chasm trap is a bad thing. It should not happen. And in the Unified Star Schema, it disappears completely. You will not have chasm traps. But it's a long story to explain why I've solved it. So I will do it one day when we have more time, or probably in more sessions, because I'm beginning to not be able to breathe. Okay. And the fun trap, is the one that, I explained it very quickly. It's when you have a table which contains numbers, measures, these things that you want to aggregate, like amount, quantity. It's usually money, but it can be also minutes, numbers that can be aggregated, summed up together. That one, together with another table, that explodes that table. So basically, you have repetitions of numbers. That's what a fun trap is. And with 2 tables, you produce that effect. And it's bad. It's really bad. Okay. Thank you, Francesco. Okay, that's not a question. This has been a great session, and I read your book and truly enjoyed it. Okay, it's not a question, but thank you for that, Sheikh. And I think this is the last question. Could Unified Star Schema be used beyond the BI? For example, yeah, exactly, Luis. That's exactly where I want to go. I'm an expert of BI, but I'm not an expert of machine learning. So probably the question, I will turn it back to the people who are in this call, and I will ask them for help. So the question is, for example, in machine learning, to help feature engineering. If so, how? I'm asking because you comment that it's not possible to do that using Python and R. Be careful. What is not possible to do in Python and R, to my knowledge, is to reproduce the in-memory association. But in the book, I'm explaining, in the chapter of the fun trap, I'm explaining that the in-memory association is only one of the possible solutions of the problem of duplicates of numbers. So that's, I want to scroll a bit quickly the book. So this is the fun trap. I first define it, and then I give exactly the example that I've given in this meeting, and then I'm showing what the problem is, and then I show the BI tools how they fix the problem. So by scrolling, I show it with the Power BI how it behaves, and I show that Power BI does exactly this thing: 4,000, but then the total is 4,600. So it's clearly not doing the sum of the numbers that appear. So with Power BI, the problem is solved. And then I say, is your BI tool capable of association? Maybe yes, maybe no. So I'm showing a test to show very quickly and very easily how you can test if your BI tool is capable of association. But then after that, I'm saying, okay, when the fun trap occurs, using a BI tool that is capable of association is the best solution in business intelligence. But it's not always possible. If your organization has a different BI tool, then a different solution is needed. And I should have written, or if you're doing machine learning. So I'm offering two different solutions. One is called splitting the measures, and the other, which is the one that I've implemented today, actually, is called moving the measures to the bridge. So when you move all the measures to the bridge, you are okay, also when you're using R and Python. And to prove that to you, I want to show you, because I've done it also in R. I'll show you very quickly. So with my friend Chan that I met at the IDE event, so I need to give credit to him. So this is my brother Chan, okay? And he was helping me with this. And you see, that's the value of going to an event like Data Science Go. You meet friends and then they help you, and I help them. And that's the whole point of networking. So thanks to Chan, I've put together this thing in R. I wanted to do it in Python, but he says R is better, so that can trigger a big discussion. And I have implemented the Unified Star Schema in R. So if you look, for example, the table countries PBS, or that's not interesting. Let's put something more interesting, sales PBS. You see this table, sales PBS, is a table that has the stage column, and then it has the PBK columns. Stage, so the sales point to clients, they point to countries, to the products, to the product lines, and to the targets. So this one is pointing to a lot of tables. But then another table, targets PBS, it doesn't point, for example, to sales, you see. So it has only a few of the possible PBK columns. And here there is a technique of splitting, the technique of moving all the measures to the bridge. So in this example, I did, okay, this is the PBS table with the PBK columns. So Pupini bridge stage with the Pupini bridge keys. And then on top of that, this table, because I want to avoid the fun trap, has additionally the measure. So this way the measures are staying in the safe place, which is the stage where they were natively coming from. So the target amount is in the stage called the targets. So no one will explode that PBS table. And if you now put all together, as I did in the table called all data, this table has basically all the columns of all the tables. And I'm showing that there is a table, there's a column called target amount, which has no duplicates. So these are the target amounts that are all coming from the targets stage. But then, because I wanted to show the problem that you may have, I created a column called target amount fun. So this one has values here, but it also has values here. And if you use this column, you will have wrong numbers. So I made this column to show that it will produce a fun trap. But if you use this one, then you will not have a problem of duplicates of numbers. Basically, with R, you can do a Pupini bridge, and that's actually the test case I've built. Okay, so I was speaking a lot. I think it's time for me to breathe. and to drink a bit of water. And somehow I think it's time to call Diane back, if she's still there, and to give back the word to her. And I guess we can go towards the one-to-one session and the closing of a nice session. Thanks a lot for so many questions.